This week on the show, we have OpenZFS and DTrace updates in NetBSD, also network security stack audit in the NetBSD kernel, which trickled down to the other BSDs. We cover performance of MySQL on OpenZFS. There are OpenSMTP results from the P2K18 hackathon, as well as legacy Windows backup to FreeNAS, how to do that, and how important the ZFS block size is in certain situations, as well as NetBSD as a router on a stick in this week's episode of BSD Now. BSD Now, episode 249, Router on a Stick, recorded for the 6th of June 2018, aka BSDCan 2018 week. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Yes, we were pre-recording this episode, as you might have suspected, because by the time you hear this or watch this, we're at BSDCan and cannot do this live. So we're doing the pre-recording, but that doesn't stop us from giving you a packed show. With headlines this week, starting with NetBSD infos about ZFS and DTrace updates landing.
Yes. So we talked about it a little bit a couple months ago when the first patches went out for review, but these are the actual commits. So in the current version of NetBSD, they've integrated the CDDL updates, which includes DTrace and ZFS, bringing them up to, so basically what they did is change their upstream from being the OpenSolaris code to being the FreeBSD port of it. So it goes from OpenSolaris to FreeBSD, then to NetBSD, because a lot of the compatibility shims end up having to be the same. And so it was much easier for the NetBSD people to port from what works on FreeBSD than to start fresh from what is in Illumos. This is based on FreeBSD revision 315983, which is just the random starting point they chose to do the work on. That revision is from March of 2017, so 14 or so months ago. So that is a little bit behind, but you know, they were catching up through the last 10 years of changes in DTrace and ZFS. So
that's a lot.
I can understand why it would take them 12 months to get that working.
That's wow.
So while there's more work to do, there is, I'm sure that catching up to 14 months of changes takes a lot less time than catching up to 10 years of changes.
Yes, definitely. And but it's good to see. And maybe there's already the possibility to import pools from different systems.
Yeah. So with this working, they would have, ZFS v5000 and most of the feature flags at least. So yeah, most pools would probably import on NetBSD as of now.
Cool.
They say that there have been 2 other changes. They now support DTrace function boundary tracing probes in kernel modules. So if you load a module, it does the right thing. And then they added mmap support for ZFS.
Ah, very good. Yeah, I can see there's still a lot of work being done, but definitely a big step forward for NetBSD in the ZFS space. And who knows, maybe one day they will pull directly from upstream without jumping through the FreeBSD shims. And maybe they find some bugs on NetBSD on different architectures where ZFS runs suddenly on the toaster, I don't know, which will be then reported back to the upstream. So there's a give and take for both.
Indeed.
It's a lot of file changes in this one. If you want to find the actual
importing, basically
in
re-importing all of ZFS and DTrace. So you probably don't want to look at the list of individual files.
Yeah.
But it'll be interesting to see how they go about catching up and how they're able to stay caught up.
Yeah, it's not just drop something over the wall occasionally. It's also the maintenance and the feedback that you get once you have people trying this out on NetBSD that needs also continuous work. But yeah, definitely check out ZFS and DTrace updates on ZFS on NetBSD, and yeah, try it out. More NetBSD news we have this week in the next item, because there's a NetBSD network stack security audit been done. And this is also over at NetBSD, their blogs, or their blog, this one. And as part of a funded project, there is Maxime Villard, I hope that's the proper name, is conducting a security audit of NetBSD's network stack, and the work will end soon, and he would like to briefly present some results and show what's been done and what the result of that is. So over the last 5 months, the hundreds of patches were committed to the source tree as a result of this work. So there's already some updates been done. Dozens of bugs were fixed, among which a good number of actual remotely triggerable vulnerabilities. Ooh, that's significant for a network stack, because remotely triggerable in the network stack is kind of remote gun to shut down certain systems. But fixing, strengthening, and simplifying is, of course, important. And the changes were made to strengthen the networking subsystems and improve code quality, reinforce the mBuf API, and many k-asserts to enforce assumptions, simplify packet handling, and verify compliance with RFCs. So this was done in several layers of NetBSD's kernel, from device drivers to level 4 handlers. And a lot of cleanup took place too. For example, they managed to remove more than 1,000 lines of code in IPsec, while at the same time improving the robustness and performance. And the kind of cleanup results in the networking code that is much cleaner or easier to understand and maintain. And with the fixes for critical bugs quickly being propagated to the stable branches, NetBSD 6 and 7, and NetBSD 8 beta, those branches also get those patches. And along the way, several changes were made discreetly. They discreetly propagated, they write, when they were considered as a good mitigation against possible attack vectors. So they list the fixes in other operating systems. So they also propagated to OpenBSD and FreeBSD. As they write, in the course of investigating several bugs discovered in NetBSD, they happened to look at the network stacks of the other BSDs or other operating systems out there to see whether they had already fixed the issues, and if so, how. And needless to say, some bugs were found. So FreeBSD had 2 security advisories as a result of that, and OpenBSD had 2, 4, 6. And NetBSD itself had 5 of those. So there's some patches going around, and the results being shared. That's good. That's the kind of collaboration that we still see in the BSDs, even though they have diverged in different directions. There's still some code sharing going on. Of course, they're focusing on NetBSD, so it's no surprise the number of bugs found there is higher than the other operating systems. Yeah, that's understandable, but at least they gave an idea where the problems were, and just, hey, look, did you fix that? And if not, then look at that. So it needs to be noted, though, that FreeBSD hasn't yet published advisories for several bugs that they reported to them, which they nonetheless fixed pretty quickly. That's just work going on. It's I think they were working on that, so it's just a matter of time. They're also posting some examples there. So there is the first one. There's also a nice picture here, IPv6 buffer overflow. And apparently in January, they discovered that in NetBSD's IPv6 stack, there's a subtle buffer overflow, which turned out to affect the other BSDs as well. And the overflow allowed an attacker to write 1 byte of packet control data into packet_storage plus off, where off could be approximately control 2. This allowed at least a pretty bad remote denial of service. By sending specifically crafted packets in a loop, an attacker could override several areas of memory with wrong values, which would eventually lead to undefined behavior and a crash. So there's the little depiction here, how this bug could be exploited. But I guess this is fixed by now, so that's been dealt with. Next up, they list the IPsec infinite loop. So when receiving
this one we had talked about before when the advisory came out, where basically the offset could be 0 and you would keep adding 0 until you get to the end, which would be never.
Yeah, so that got fixed and properly addressed. And the next is that the IP proto typo was also discovered. So now you're saying, well, how security relevant could a typo be? But it turns out it is. By looking at the IPv6.
So in the IPv6 multicast code, he stumbled across a mistake where at one point it would return IP proto none instead of IP proto done. So one character off, and it happened to be a character off where it would actually still compile because it wasn't a bogus variable or bogus enum, but just happened to be a slightly different one. So returning none instead of done was entirely wrong. It caused the kernel to keep iterating on the IPv6 packet chain while the packet storage had already been freed. So you're trying to read through the memory after you've freed it, and that's bad. Then there was a PF signedness bug. It found in NetBSD's implementation of the PF firewall from OpenBSD, and it doesn't affect any of the other BSDs. In the initial PF code, this macro was defined as a number, but NetBSD changed to using a size of to automatically size it. The problem being that size of returns an unsigned result, whereas the number was a signed number, and because it was used for calculating the difference of something, it could cause all kinds of badness.
Yeah.
Then there was an interesting integer overflow in NPF, NetBSD's new native firewall. In this one, you could basically cause the firewall to inspect the wrong part of the packet. So you can see in the diagram, you see the destination address header, and it would normally point to this TCP header over here. But you could trick it into reading this other part of the packet. So you could send a packet and then put a fake header somewhere else in the packet and trick the firewall into reading that. And so suddenly the packet matches a completely different rule and is allowed through because it comes from a trusted host or whatever. And basically would allow you to trick the firewall into doing something different with the packet than what the packet should actually do. And then there was an IPsec fragmentation attack, where, as it turns out, when reassembling fragments in v4 or v6, the kernel is not removing the packet header flag from the secondary mbuffs in the chain, right? So only the first one is supposed to have this. The flag is supposed to indicate that this mbuff is the start of a chain, but all of the mbuffs had it because they weren't being removed when they were assembling the packet back into one big packet. And then later in the code, it would assume that if you saw this header, it was the beginning of the packet or whatever, and get the wrong length and then trigger a remotely triggerable denial of service attack that could crash the system. So then they say, what now? They say, not all of the protocols and layers of the network stack have been verified because of the time constraints and also because of unexpected events. With the recent x86 CPU bugs like Spectre and Meltdown, he got pulled off of this network audit project and working on those mitigations instead. So a to-do list will be left at the end of the project, and someone else can pick those up and continue to work on them, or perhaps he'll come back for another round of work on this in the future. So this security audit of NetBSD's network stack was sponsored by the NetBSD Foundation and serves all users of BSD-derived operating systems. OpenBSD and FreeBSD both got fixes out of this work. The NetBSD Foundation is a nonprofit organization and welcomes any donations that might help continue funding projects of this kind.
Yep, it's certainly good to get those fixes in the other project, and donations make these kind of things possible. This week's episode of BSD Now is brought to you by our sponsor DigitalOcean. Head over to DigitalOcean and check out what kind of virtual machine products they have in their little cloud called the DigitalOcean cloud. And they have the machines called droplets, and they have them in different sizes, from small but still powerful enough to host most open source projects, or at least the software they're producing, up to a lot of CPU and memory in case you want to go a little bit bigger. And they have a coupon code from our special section here. It's called FreeBSD Now, which gives you a $10 credit, and that gives you something to start with. But Alan still has a bigger code, I think. Is that still valid?
So if you already have an account with DigitalOcean, but you haven't used the coupon code before, go to DigitalOcean.com and either sign up for an account or log into your account and enter the coupon code FreeBSD Now, and it adds $10 in credit to your account, which you can do whatever you want with. The other one is if you go to dio, as in DigitalOcean.co, as in company, /BSD Now, it'll take you to a special super secret page. And when you sign up for a new account there, they'll give you $100 in credit for the first 60 days to do whatever you would like to do.
Yes, because then you can start a droplet that has already some software on it, or like 10 of those, then build a little cluster, like a MongoDB cluster, or something that you couldn't do on your laptop at home or in your workstation. And that's exactly what you can use the cloud for. Test it on the cloud, and if you like it, then, well, ask your boss to buy you the horsepower for the actual systems, or run this in the cloud indefinitely. That's no problem as long as you pay the bills. That's pretty much the same service that you can expect from a local deployment. You can also use the one-click app, so definitely check those out, because then you can run a very simple node that runs Ruby on Rails stack, or your WordPress blog, or some Django, whatever you need. It's probably already been packaged for you. And you can also check out the community section on DigitalOcean's website, which has community-provided how-tos and tutorials. And they give the tutorial writers money so that the tutorials have not only the quality, but also the actuality, and that the authors get also something back for their troubles of writing those. You can also find in their web GUI a very nice way of looking at what kind of machines are running, what kind of CPU and RAM they're currently using, and how much bandwidth they've already used up from your monthly available bandwidth. So that's quite comprehensive. And if you are more into the programming, and if you have a lot of droplets to manage, like creating and destroying them, you can check out the API, which lets you controllably automate your droplet deployment. So you can use Ruby, Curl, Go, or their own DigitalOcean control panel.
Yep. So on to the next story.
Yep. That's also interesting for the people who can't get enough of ZFS, because this one is MySQL on ZFS performance comparison, or at least little benchmarking. That's over at the Percona website. Yep.
Yes. So with this one, they're basically following up to the post we talked about the other week when we showed the videos from the ZFS user conference. Mm-hmm. So one of the people that was doing this performance testing over at Percona presented it at the OpenZFS Dev Summit and kind of got some feedback.
Oh, excellent.
So one of their coworkers presented a new set of benchmarks. So they say, I use Sysbench to create a table with 10 million rows, and then use the export-import tablespace feature to copy it 329 times, ending up with 330 tables for a total size of about 850 gigabytes for the database. The dataset generated by Sysbench is not very compressible, but they used LZ4 compression in ZFS anyway. For the other ZFS settings, they used what they found from the earlier post, which includes setting the arc size to only 1 gigabyte, which is probably not a great plan. But they're following the standard MySQL advice of letting the MySQL InnoDB buffer cache deal with most of the caching and so on. It is possibly unfair doing that compared to when benchmarking versus XFS, which is going to use the OS buffer cache without that strict size limit necessarily. And as we explained at the ZFS user summit, ZFS is doing a lot more work than XFS. So in a straight up test, you would expect ZFS to be slower. It's doing extra work to guarantee the safety of your data that XFS is not doing.
Right, and that doesn't normally not necessarily or directly translate into performance.
Right, is what the extra work ZFS has to do is always going to make it slower.
But it's secure this way. You get your data back.
Things like the ARC can make it smarter than other file systems.
Exactly.
So anyway, he then used a plain configuration for the first benchmark. Here are the results. This is with the InnoDB buffer pool set to 2.5 gigabytes. And you can see that with XFS, they got about 3,000
and then levels off.
Requests per second. And with ZFS, about half that at a little over 1,500. So in both cases, it was completely IO bound. The disk is doing exactly the allowed 3,000 IOPS. They were using an Amazon instance with provisioned IOPS. The above graph appears to be a clear demonstration that XFS is much faster than ZFS, right? But is that really the case? The way the dataset has been created is extremely favorable to XFS because there's absolutely no file fragmentation. Once you have all the files opened, each read IO is just a single fseek call to get to the offset in the file and read it from the disk. And ZFS doesn't need to access any intermediate inode. The above result is about as fair as saying that MySQL is faster than InnoDB based only on table scan performance for unfragmented tables in the default configuration. So then it goes on to talk a little bit about how ZFS metadata works with the B trees. And you see at the root, and then each of those nodes, the indirect nodes, points to leaf nodes, and those leaf nodes actually contain the data in your database. The extra IOPS performed by ZFS are needed to access these internal blocks in the B tree of those files. These internal blocks are labeled as metadata. Essentially, in the above benchmark, the ARC is too small to contain all those internal blocks, just the metadata about the data in your database. If we can continue the comparison with InnoDB, it'd be like running with a buffer pool too small to contain all of your non-leaf pages. The test data set that we used was about 600 megabytes of non-leaf pages, about 0.1% of the total size, which was well cached by the 3 gigabyte buffer pool. So only one InnoDB page, a leaf page, needed to be read for each select statement. To correctly set the ARC size to cache the metadata, they go over some of the math and a bit of experimentation to help find, what the right amount is. And they found that because they're using small pages and so on, they might need as much as 6 gigabytes of ARC, which isn't really that much, but their VM that they're running this only has 15, so maybe that's a lot. But then again, if their MySQL buffer cache is going to be 3 gigs, what's the rest of that RAM going to do? Might as well use it.
Sure, for certain.
So they actually delve into using the ZDB tool to actually look at the internal structure of the data and understand what ZFS is doing internally. I recommend you go check that out if you're interested. But then they looked at, well, what happens if we can change the InnoDB page size, which you could start doing in MySQL 5.7, so that we could increase the ZFS record size and have a less metadata per data. So with that, suddenly going up to 64K pages instead of 16K pages drops the metadata overhead level from 0.8% to 0.2%.
Huh. And that makes the difference?
Yeah. And then they also played with using an L2 ARC device. Although, in most cases, in this case particularly, they probably would have been better off with just adding an extra 8 gigs of RAM and letting the ARC do it in the ARC. But going to a bigger sized Amazon instance costs quite a bit more versus adding an extra device to the EVM.
Yep.
So they showed some of the tuning they did, setting the ARC metadata limit to 8 gigs and playing with it a bit. And then running, they noticed that, well, XFS is still doing its 3,000 IOPS, or 3,000 queries per second. ZFS is now able to do 5,000 queries per second. So it went from 50% as fast to 166% as fast.
Yeah, that's something people want to have in
and then you start considering, using LZ4 compression. The larger record size means that you get even higher compression. You're already compressing the metadata. The other one that they haven't dealt with yet is there's a setting in ZFS called redundant metadata. It's a property on a data set, and it's specifically designed for databases to say, especially when you're using the smaller record size, like 16K, only keep 2 copies of all the metadata instead of 3. And that will be that many, 1/4 less IOPS used for metadata on every write. It wouldn't affect this benchmark because they were only benchmarking the read speeds, not the write speeds. But it can make a difference in both the space overhead and the IOPS overhead of using databases on ZFS.
Yep. What would be interesting to see XFS on a ZFS volume in that benchmark?
That would just end up caching things twice, and it's not great.
Yeah.
I wish I had time. I'd love to set up this same thing, recreate the results, and then apply my tuning understanding and see how much different that gets.
So for example, MongoDB recommends to use XFS instead of the other Linux file systems out there. And this might be something people should look at and reconsider using ZFS, because with a little bit of tuning, you can get a bit more reading done.
In this case, again, it falls back to my other advice. Don't just do random things you found in a blog post to your pool.
This is a specific.
So don't just do what this guy did. And also don't do the meta thing he did, which is read a previous blog post from his company's website and make the same mistakes again. But in particular, adding an L2 ARC when you only have 15 gigs of RAM is probably hurting you, because it takes RAM to say, hey, this data is actually on the L2 ARC. If your L2 ARC is too big, you're actually spending most of your RAM pointing to the device that's not as fast as your RAM, and just caching more stuff in RAM could have been better. But because he had limited the size of the ARC so small, it's much less than his working set of metadata, it wasn't the normal trade-off.
Yeah, it's a synthetic benchmark for one certain kind of read.
And if your database is read-only and you're using ZFS, what you really do is, turn the record size way up, get all the compression, and just fit the entire database in RAM.
Yep, that's how you do it. But if you have a whole different, like a write going on, or more writes than reads, then this is not a general suggestion. So tune it to the workload that you have.
The important point of this post was that, contrary to the previous post, it is possible for ZFS to be faster.
Sure, yeah.
It just really depends on the tuning and your workload.
Yeah, it's not the end result. You can do more. All right, very nice. We also have an OpenSMTPD new config, which resulted from the OpenBSD P2K18 hackathon, which took place in Nantes. And it starts with a too long didn't read at the beginning. They were organizing the hackathon, but managed to make progress on OpenSMTPD, which is OpenSMTPD, the mail server from OpenBSD. Or from the OpenBSD project. As mentioned at EuroBSDCon, the one-liner per rule config format was a design error. A new configuration grammar is almost ready and the underlying structures are simplified. Refactor removes roughly 750 lines of code and solves many issues that were side effects of the design error. So new features are going to be unlocked thanks to this. So that was just the summary at the beginning. And now they go a little bit more into the actual anatomy of the design error, where this came from and what kind of what kind of things came out of that. OpenSMTPD started 10 years ago. Oh, wow. Has it been already 10 years? Ooh, cool. Out of dissatisfaction with other solutions, mainly because they considered them way too complex to get things wrong from time to time. And the initial configuration format was very different, inspired by Pure's, Pure is the username, the nickname, host state D, which eventually became relay D and designed the configuration format with blocks enclosed by brackets. And when they first showed OpenSMTPD to Pure at OpenBSD, he convinced them that PF-like one-line rules would be awesome, and it was awesome indeed. It helped them maintain their goal of simple configuration files, helped fight feature creeping, it helped also gain popularity and became a relevant mail transport agent, and it helped us get where we are now 10 years later. Okay, see, design is important, and if you start on the wrong design foot, then it bites you later. That being said, they believe that actual thing was a design error, which could have been predicted until they hit a wall to understand why this was an error. One-line rules are semantically wrong. They're SMTP wrong. They are wrong. Oh, there's a lot of wrongs in here. Yeah, okay. So, that being said, to get to the point, one-line rules are making the entire daemon more complex, preventing more features from being implemented, making others more complex than they should be, and they no longer serve our goal. So to get to the point, we should move to the two-line rules.
Right.
Okay.
So just to give you an idea, the previous way one of these rules would look would be, except from any for domain poolp.org delivered to mbox. And it was actually one rule trying to do multiple different things. First, the decision on whether we should accept or reject, the matching, from any to domain poolp, and the action delivered to mbox. To ensure that we meet the requirements of the transaction, the matching must be performed during the SMTP transaction before we make a decision on the recipient. Given that the rules are atomic, it doesn't have some identifier, and that the action is part of the rule. There, the two only ways. It's French people. To make sure we remember the action was to actually add it to the envelope of the message while we're processing it, and this gets tricky, and both solutions are not okay. So they looked at a couple different solutions and then decided to separate the action and the match rules.
Okay.
So the first solution, which we've been using for over a decade, was to save the action into the envelope and kind of carve it in stone. This worked fine. However, it comes with the downside that errors fixed in the configuration files can't be caught up by envelopes, that delivery actions must be validated way ahead of time during the transaction, which is much trickier, and that the delivery method takes place in the SMTPD user rather than the recipient user, and that envelope structure that are passed all over OpenSMTPD carry delivery time information, and it's a layering violation basically. The code becomes more complex in general, less safe in a bunch of places, and some areas are nightmarish to deal with because they have to deal with completely unrelated code that really shouldn't be in this part of the code path. So the second solution can't be done. An envelope may be the result of nested rules. For example, an external client hitting an alias, hitting a user with a .forward file, resolving to some other user. An envelope on disk may no longer match any rule, or it may match a completely different rule. If we could ensure that it matched the same rule, evaluating the rule set may spawn new envelopes, which would violate the transaction. Trying to imagine how we could work around this leads to more and more RFC violations, incoherent state, duplicate emails being sent, and so on. There's no simple way to deal with this with atomic rules. The matching and the action must be two separate units that are evaluated at two different times. Failure to do so will necessarily imply that we're either using our first solution with all of its downsides, or that we are currently in a world of pain trying to figure out why everything is burning around you. So, switching something to kind of like the newer PF syntax, they have match rules. So you can match on TLS or on authenticated user or from a certain socket or with a certain hello field or whatever. You create your match rules, and then you create actions and tell them what to do. So for example, you say match from any for local and then apply my action. Then separately, you have an action called my action, and it says, deliver to maildir.
Okay.
This way, you process those two separate rules at different times, and you don't end up in this problem where you have to kind of remember some of this stuff for later.
So, time for the news roundup. This week, we have something a little bit strange at first, but it makes sense once you realize where this is going. Backing up a legacy Windows machine to a FreeNAS with rsync. That's where the reference to BSD comes from.
Mm-hmm. So the post goes on. I have some old Windows servers that are 10 or more years old, and I've been using rsync to back them up my FreeNAS box, and this is worked very well for me. So he walks us through it. First of all, I do have my Windows servers back up in virtualized format. However, those are only one-time snapshots and only run once in a while. I really want something more frequent. There are classic ASP IIS web servers that I can easily put in a new VM. However, many of these legacy servers generate gigabytes of data a day in their repositories. Running a VM convergence daily is really not ideal. So the solution was to use some sort of rsync solution just to do data deltas. I've tried some applications that don't work so well with Samba shares, and these old servers have slow I/O. Copying files to external SATA or USB drives was not ideal either. We moved on from Windows to Linux, and we do not have any Windows file servers for capacity to provide network backups. Hence, I decided to use Delta Copy with FreeNAS. So here's just a little write-up on how to do it. In this case, they have 4 Windows 2000 servers backed up daily with this method. Wow, Windows 2000. Jeepers.
It's been a while, yeah. Ooh.
Yep. First, they went and downloaded Delta Copy and installed it. It's an open source and it's free. It's basically a wrapper around Cygwin's version of rsync. When you install it, it will ask you to install the server services, which allow you to run an rsync server on Windows. We're not going to do that in this case. Instead, we will just run the Delta Copy client application. Before we do that, we need to configure our FreeNAS to run an rsync server. Using the rsync native protocol instead of SSH is definitely going to help with the speed and lower the CPU usage in this case. So, in your FreeNAS, go under Services and select rsync. And then under rsync modules, create a new one. Then you can fill out a little bit of information about the rsync module, basically giving it a name and telling it what dataset to store the data in. So, ideally, I imagine you create one of these for each of the servers you're backing up, because each one will be a different dataset.
Yep.
So you fill out that form, and you're pretty much good to go. So this process is much easier than trying to configure the rsyncd.conf by hand. There's the value of the FreeNAS GUI. Now, on the Windows client, start the Delta Copy client and create a new profile. You'll need to enter the IP of the rsync server, which will be your FreeNAS, and specify the module name that you just created, which will basically be the virtual directory, or the share name if you're from Samba. When you pull the select menu, the list of rsync modules you created earlier should auto-populate once you've given it the IP address of the rsync server. You can set authentication on the server. You can restrict by IP and do other things to lock it down. Next, you add the folders or files you want to copy to the FreeNAS. Once the paths are set up, and you run a sync by right-clicking the profile name. Here, I made a test sync of the home folder in the virtualized Windows box. As you can see, I mounted the rsync volume on my Mac, and I can actually see the progress.
Okay. Oh, those old Windows screenshots. Gee.
So
Okay.
rsync works beautifully, and Delta copy gives you a nice GUI on top of it. Once you get everything working, the next thing to do is set it to be scheduled. So just do this with the task scheduler in Windows, which is basically the Windows version of cron tab, and set it up to run automatically. And there you have it. You're now backing up files with rsync to save or to deal with modified files, and pushing it to your FreeNAS, where you can create snapshots and replicate it offsite, or just store it in a way where it's actually protected from bit rot.
Yeah, on ZFS for added security and protection.
Yeah.
Which brings us exactly to our next sponsor, because if you hear FreeNAS, then yes, of course, you think iXsystems. And yes, that's the folks that are doing FreeNAS and doing it well. They also sell you the hardware for it in case you have a backup need in a more bigger or smaller environment. They can give you a FreeNAS Mini XL up to the big server rack just for backup purposes. But not only that, they can also build you a server that's exactly fitted for your needs in the open source space. Let's say you want to run an open source application of certain kind. You're not sure, does this need more memory? Does this need more hardware? Does it need more CPUs? Call up iXsystems. They will build you such a system for your specific purpose.
Yes, even if that purpose is just backing up all the Windows machines at your office.
Yeah,
that's
totally valid.
FreeNAS, like half of the point of FreeNAS is backing up those Windows machines because you don't trust them.
To do the job.
How FreeBSD gets a foothold in all of these regular everyday offices where everybody uses Windows, is because sure, you use Windows and it works great, that's fine. But you need your data to be more durable than that. So get it backed up to that FreeNAS. Whether you're accessing it directly off the FreeNAS using Samba or NFS or Apple FS if you're running Macs or whatever. But get the backups and get the important files on the FreeNAS, get the snapshots, protect yourself against ransomware and accidentally deleted files and corrupted hard drives, all those things.
And it's super easy. Like we showed you in the previous article, it's a web GUI where most of the things are so easy to configure. You wonder how you never done this before. It's just so easy because it's all menu driven, and iXsystems put a lot of focus on that.
Backups need to be easy or they won't get done. And if they don't get done, you'll regret it.
Yeah, if that's too complicated, then something might get missed or overwritten accidentally. And so that's why iXsystems put a focus on making that easy for end users and also the non-IT people, that they can also set this up.
Yep. So
and if you run out of disk space,
head over to iXsystems.com/BSD Now and get in touch with them. I just did. Turns out, out of space again. So it's like, hey, IX, I need another 12 terabyte disks.
Is it Monday again?
And I'm going to need to start making decisions about adding more shelves. So I want to start looking at my options there. What's the best option for me to fit the most hard drives in the available rack space? It's interesting. At some point in the past, it was like, well, the rack space is the least of my concerns. I got lots of rack space. Well, that rack space is all full of hard drives now. Yeah.
It's extensive, yeah. But they still have ideas how you could solve that problem. And discuss solutions with you, not just to sell you something, but also figuring out, this is the need in 5, 6, 7, 8 months or years. Probably. So
exactly. So on to our next article, how to write ATF test for NetBSD. So ATF, or the Automated Testing Framework, is a way to write basically integration tests and CI/CD type stuff. So tell us a bit about this.
So this is over at the r3xnation.wordpress.com. They have recently started contributing to the amazing NetBSD Foundation. They were thinking of trying out a new operating system for a long time. Switching to the NetBSD operating system has been a fun change. Their first contribution to the NetBSD Foundation was adding regression tests for the address sanitizer, the ASAN, in the automated testing framework, ATF, which NetBSD has. They managed to complete it with the help of their really amazing mentor, Camille. And this post is going to be about the ATF framework that NetBSD has and how you can add multiple tests with ease. And since the ATF test framework has been ported from NetBSD to FreeBSD, those tests could also be reused in FreeBSD and other systems that use ATF. But that's me as a side point. The intro to that goes, in ATF, the tests will basically be talking about test programs, which are a suite of test cases for a specific application or program. And the ATF suite of commands are a variety of commands that the ATF suite offers, which include ATF-check, which is a versatile command that is a vital part of the checking process. There's a man page for that, of course, so you can read up all these specifics there. There's ATF-run, which is a command used to run an actual test case, and ATF-fail to report an actual failure of a test case. If something goes wrong, you want to know about this. The ATF report is used to pretty print the ATF-run output, and ATF-set is used to test ATF test conditions, so true or false or equals 1 or something like that. It depends on the test you're writing. So they will be taking a better look at the syntax and usage later. The basics is basically ATF testing framework comes pre-installed with a default NetBSD installation, so it's already there on the system and used to write tests for various applications and commands in NetBSD. One can write the test programs in either the C language or in a shell script if you're more versed in that. And in that post, they will be dealing with the bash part. Well, careful here, shell scripts unequal shell bash scripts. So, okay. But there are more links in the, because it's a rather long article, but well worth the read if you're interested in starting to write tests, because that could lead to a more involved career, if you want to call it that, with kernel programming, or at least userland programming, because you wrote tests for that. And they tell you how tests are written, what kind of structure they have. So this is pretty comprehensive to get started with.
Yeah, it kind of walks through the basics of creating a test from scratch, basically, which is something I've been looking for because I'd like to add some ATF tests for some stuff and didn't have an understanding of how to get started at first.
Yeah, because if you can test it and you are sure that there will be no regression sneaking in or stuff that you thought would work suddenly blow up in your face and you don't know where this came from. If you have a test, then your code is much more robust.
Well, in particular, ATF and QA are part of FreeBSD as well and use for our test framework.
Mm-hmm. Yeah, that was ported over, and there's, I think, also a bit of sharing going on with tests because of the heritage that both BSDs share. Excellent. Our next topic is one for Alan again, the importance of ZFS block size.
Yes, so again, I preface this article with, warning, don't just do stuff because somebody's blog says it was a good idea. But anyway, it goes on. It says, one of the important tunables in ZFS is the record size for normal file systems, or the vol block size for zvols. And the defaults are 128K for a file system, or 8K for a zvol. As I understand it, this is the unit of work in ZFS. If you modify 1 byte of a large file with the default 128K record size, it causes that whole 128K to be read in, the 1 byte to be modified, and then that whole 128K to be written out. As a result, the official recommendation is to use a block size which aligns with the underlying workload. So for example, if you're using a database which uses 16 kilobyte pages, then you should use a 16 kilobyte block size in ZFS. If you have a VM that's containing, a regular file system, you might consider a 4K block size. Although most file systems, while the sectors are 4K, have a larger cluster size, and you might get away with doing that as well. Mm-hmm. So they looked at a file they have, which is a 16 gigabyte disk image, but it actually only contains 8.5 gigs of data. Basically, it's a sparse file. It was created as 16 gigabytes, but not all of those bytes have ever actually been written to, and so they just contain nothing.
Yeah.
So if they copy this over to ZFS, we see it takes the same amount of space there, that 8.42 gigabytes. However, when they created a ZVol and copied the file over using either DD or QEMU image, they found that suddenly it was taking 14.6 gigabytes, and they were slightly confused. They're like, why is my 8.42 gigabyte file suddenly taking 14 gigs of space, which is almost the entire 16 gigabyte size without all the sparseness? And they thought maybe the problem was the QEMU tool, but when they used DD, they got the same problem. Then they tried it again, but set the block size of their ZVol to 128K. And suddenly, the file went back to the size they expected, 8.42 gigs. So what's going on here? Well, part of it has to do with the metadata overhead. For each block you have on your ZVol, ZFS has to keep all those indirect blocks, like in that tree we saw in the ZFS database article earlier. Well, those blocks take space. And when you use 8K instead of 128K, you need a lot more of those blocks. And it can actually impact speed. So in their little test here, they read from the file using 4K blocks, and then again using the 128K blocks, and they found that it takes 5 minutes and 52 seconds to read all the 4K blocks, and only 3 minutes and 20 seconds to read it with the larger blocks. And again, that's true, and the larger block is better, except, remember back to the beginning, if you change any portion of the 128K block, you have to read the whole thing, modify it, and write the whole thing. If you're making tiny changes, that's a waste, but it can get really bad when you're doing something like a database. If you have the 128K record size and you're actually modifying 8 or 16K at a time, you can end up doing a lot more work, especially if you take the 128K, read it in, modify the first 16K, write out all 128K, then read it back in, which ZFS, you probably won't have to read it back in, it'll be in the ARC, but then you're going to modify the second 16K and write that out, and then modify the third 16K and then write that out. And because it's copy on write, you're keeping a separate allocation for each of those, and suddenly you're doing a lot more work than you needed to do. And, if you only have so much write IOPS or bandwidth for your database to write to the disk, and you're writing, many times more than you need to, you're going to end up wasting a lot of time, right? If you're doing 8 times the work you need to do, it's going to be 8 times slower than not doing the excess work.
Yeah, and with the data sizes that we have nowadays, waiting 8 times longer than necessary. Well,
another thing they didn't talk about was what their zpool layout was. Depending on the record size and the sector size of your disks and the RAID Z level you're using, padding can also come in. If
true.
you're using, say, RAID Z2 and the default 8 kilobyte block size, and your disks are 4K sectors, then on RAID Z2, every allocation must be a multiple of 3 sectors, right? Because you'll have 1 data sector and 2 parity sectors as the minimum. If you ever end up with some allocation that's not divisible by 3, you could end up with a hole somewhere on the disk where you have 2 sectors of free space, but you can't write something that small because you need to save 2 sectors of parity for it. And so you would end up with free space that you could never use. So to prevent that, it always rounds it up to n plus 1, where n is the RAID Z level. So because if you have 8K of data, so that's 2 sectors, and then the parity for it is 2 sectors. You're going to write 4 sectors, but you have to round it up to a multiple of 3. So then that's 6 sectors. So you ended up writing 2 blank sectors of just padding. And now you're using up more space on the disk and just not filling it with any data. Whereas if you used maybe a larger sector size, the padding level might be different, right? If you had 16K record size, that's 4 sectors. And then you add 2 sectors of parity. And then you round that up to be divisible by 3, which requires having 0 more sectors. And now you're not wasting any space. And so that can also impact the numbers on some of this stuff.
Yep. So storage planning and knowing what kind of workload this pool is going to serve will go a long way into the performance space.
Yes.
To get you.
And then the other thing is, the other advantage of the larger sector size or larger block size in ZFS is more compression. Right? Once you have compression on, the bigger your record size, the more data you get to compress at once, so you can find more redundancies and more duplicates to compress. And that can end up making it take less space, which can be very confusing.
But the benefits are clearly visible.
Yeah. So it really comes down to you have to see what your actual workload ends up being like. But I imagine if they had even stuck with the 4K sector size and then enabled compression, they might have had some advantage. Although with 4K sectors, you're actually not going to get any compression advantage because you can't compress something down to less than 1 sector. So for ZVols, you probably almost never want to use 4K. It might have made sense when you had 512 byte sector disks, but with 4K sector disks, it just doesn't make sense.
Yeah, they're more and more common.
Yeah, so you might consider 16K as maybe a good sweet spot there.
All right. Next one is a good tie into our show. We have an article here using a Raspberry Pi 2 as a router on a stick starring NetBSD. So first of all, we're being mentioned in this article, not replying quickly enough. So first of all, sorry, we're busy as you can imagine. We'll cover this now so that we try to catch up on this. So what's this all about? A few weeks ago, the author of the blog post, Kev, set about upgrading his feeble networking skills by playing around with a Cisco 2970 switch. He set up a couple of VLANs and found the urge to set up a router to route between them. The 2970 isn't a modern layer 3 switch, so what am I to do? Why not make up or use the Raspberry Pi 2 that he never used and put it to some good use as a router on a stick? So he could install a Linux-based OS, as quite familiar with it, but where's the fun in that? In his home lab, he used SmartOS, which, by the way, is a hot hypervisor, but as far as I know, there aren't any Illumos distributions for the Raspberry Pi. On the desktop, I use Solus OS, which is by far the slickest Linux-based operating system that I've had the pleasure to use, but Solus focused is purely desktop. It's looking like BSD then. So he believes FreeBSD is renowned for its top-notch networking stack, and so he wrote to the BSD Now show that you might know on Jupiter Broadcasting for some help, but it seems that the FreeBSD chaps from the show are off to jolly some BSD conferences. Well, if only that. For another, but love the show, by the way. Thank you. So we now try to catch up on this. So let's go with the actual how-to. Download the image and install NetBSD on micro SD cards. So that's described here as a quick how-to. Then you boot that up and make changes to your SSHD config because you want to kind of access your little Raspberry Pi later on. And they were trying to create the VLAN interface, which apparently didn't work, or at least are not enabled, the VLANs in the kernel. So not using RPi to build, too slow. Yeah, so spin up a NetBSD VM in VirtualBox to get the freshest sources so that you have the VLAN support and other stuff. And then they go through the usual build prep, like building the sources for the Raspberry Pi, which can take a bit of time, but this is NetBSD, of course, where you can cross-compile for other architectures. So in this case, ARM v7. And so the building instructions are all there if you want to follow this along. And upon a successful build, you should see something like, well, build finished. Don't look at the time it took, but as long as you have a working kernel, that's fine. Woohoo! They have a kernel, and that you can now use to build your system for the Raspberry Pi 2. And then you can, he's testing for the actual VLAN ability in the kernel. That was the actual goal of the whole exercise. And yeah, looking good. They can now create the if configs with the VLANs, and there are no errors anymore. And then they can start creating the routing, for packet forwarding and things like that. So that's been all detailed in this article. And yeah, should get you running with your little router on a stick on NetBSD with the Raspberry Pi 2, or even the Raspberry Pi 3 could also do this. Time for the Beastie Bits this week, starting off with BSD Jobs website, which is, I guess, relatively new, but important because a lot of people are looking for jobs in the BSD space or with FreeBSD. So this one should hopefully solve that. At least if you have a job posting, then send it to them and they will put it on the website and on Twitter so that everyone can see it.
So the first one they have there is Rick Fleuter of OpenBSD says, "Hi, I'm moving to Switzerland and I'm looking for operating system developers to join my team at Architrust, a company in Zurich. Sorry, no remote work, but they'll be doing OpenBSD, C, and virtualization with some Rust." There's also a position for a system administrator at Netcetera in Macedonia, and a software developer system infrastructure person at WhatsApp. So WhatsApp is looking to hire people who can write clean, awesome, bug-free Erlang, C, and C++, and work with multi-node clusters, and have an understanding of Unix internals, especially FreeBSD, knowledge of TCP/IP, and experience with network programming, experience building and scaling distributed, highly available systems, and are able to work in a team. And they prefer 2 years of experience with Erlang, C, or Python.
Mm-hmm. Okay, so yeah, follow this site or visit it regularly in case you're looking for a job. There might be something new there. Good luck to Reich also for his move, and to Architrust for finding new people. Next, we have a repeat, but still important thing, that the University of Aberdeen's Internet Transport Research Group is still hiring, and you should look into their positions that they have.
Yep. So if you want to work on internet transport research, which means, TCP/IP and networking, they have a research fellow and a research assistant position. So whether you're, relatively new to this or old hand, either way, they have jobs at the university in Scotland.
Mm-hmm. So this is something more academic, but nevertheless interesting work.
They're doing good work. If you've seen, we did an interview with Tom Jones, who's one of the people you'd be working with. I guess it'd be 2 years ago at FOSDEM. And we've also talked about some of the other stuff he's been working on in the meantime. So if you want to keep working on making the internet actually work better, you should check that out.
The next item we have is a VR demo on OpenBSD via OpenHMD with, so now there's a couple of acronyms here, OSVR HDK2. This is a YouTube video.
OpenBSD and OpenHMD are not already acronymy enough.
Yep, but the video is basically the VR demo from like the stream or from the camera directly.
Mm-hmm.
Okay.
Anyway, worth checking out if you're into virtual reality.
Yes, if you can't get enough of ed, then this next item is something to your liking. Patch runs ed, and ed can run anything, which mentions FreeBSD and OpenBSD in the article.
Yes, I know for a while there was a version of ed called red, which was a restricted ed that had fewer capabilities so that you couldn't quite convince the patches to do evil things. So in this example, they have a patch that says you should run touch on /tmp/owned and then run ls on it. And then when you try to apply the patch, it puts some random stuff. And you're like, what? What's going on here?
Yep, that's the power of ed, which is something you probably didn't learn in your Unix class, but it can do some interesting things.
Yeah, so they say it looks like FreeBSD fixed this sort of thing back in 2015, although GNU patch, as shown above, clearly has not. And OpenBSD also patched theirs back in 2015. It looks like they had it first, which I suppose makes sense. Also, I'm hearing that it can't exec other programs anymore, which is very awesome.
Very cool. And next item we have says that Alacrity OpenGL powered terminal emulator now supports OpenBSD. So go over their website. It's on GitHub and check out what it looks like.
It also supports FreeBSD, Linux, and Mac OS.
And Windows support is planned before the 1.0 release also. So this is a cross-platform thing then. Very nice. GPU accelerated. Excellent. Wow. Well, should take a look at that.
Then we have a little bit of a late update to the map stack stuff. So
yeah, this is...
In OpenBSD, they've committed the map stack option for mmap, which synchronous faults, page faults, and syscalls confirm the stack register points at all map stack memory. Otherwise, a sig fault is delivered. The signal stack, or signal T stack, and pthread set stack are modified to observe the map stack flag and can only set and clear that by mmap, which zeroes all the contents of the region. There is no mprotect equivalent operation, so there's no map stack adding. You can only declare it ahead of time. This opportunistic software emulation of a stack protection bit makes stack pivot operations during ROP chains fragile, kind of like removing a tool from the toolbox.
Okay.
And as we're all thinking about conferences right now, as we're over live at the first day of BSDCan, remember your time is running out to submit your paper or tutorial for EuroBSDCon, and come join us in Romania.
Yes, submit something that gets you there, giving a talk or a tutorial. If you're more into the teaching part, submit something. Why not? What could, the worst thing is say they don't accept it, but yeah.
This part is not very hard. Send them a short and concise text description. So about 100 words explaining what you'd want to talk about, and then give a short CV about yourself so they know who you are, and an estimate of your travel expenses so they know what it'll cost to bring you over to Romania.
Yeah, and once the call for paper is done and they announce the talks, we will cover it in the show, of course.
You have until early on June 17th to submit, so you only have about 2 weeks left to pick a topic and write up your 100 words and send it in. Yeah,
mark this red in your calendar to not forget it. Submit in time, otherwise the deadline runs out without you submitting something.
And again, you are ashamed for the rest of your life.
Yeah, and you don't have to be the big kernel change maker. You can do a talk about how you introduced BSD in your workplace or some other environment, some interesting things that you're doing with BSDs. It's not just kernel hacking and user space stuff. It's
a little project I've been thinking about and talking with some other people about was trying to come up with kind of a list of talks we would like to see so that people that didn't exactly know what to talk about could look through it and be like, hey, I actually know a lot about that topic. I didn't think anybody would be interested. It's like, actually, that's exactly the one we were looking for.
Fill that spot. Yeah. Yeah, that would be good. So at least give an idea what people are interested in. Very nice. So that's for the Beastie Bit section. But before we head into the feedback and questions section, we should mention the sponsor for that one, Tarsnap, of course, which we will also see at BSD Can because they're sponsoring the Dev Summit, the T-shirts. And Tarsnap is the online backup for the truly paranoid. They give you the security to sleep at night knowing that no one else but you can decrypt the files that you stored into the cloud.
Yep, it only takes $5 to get started, so you have no excuses. And, as we mentioned earlier, backups have to be easy or you're not going to do them. So Tarsnap makes it super easy. One little command, say, hey, create this Tarsnap archive, put these files in it. It automatically deals with segmenting your data and deduplicating it, compressing it, encrypting it, and sending it off. You barely have to do anything. You just got to tell it, these are the files I want to back up, and these are the files I don't want to back up. And it does it. And it's
quick and easy.
Pay as you go. So you put the money in and you use it up until it's gone, and then you put more money in. It means you never get a surprise bill because you can never spend more money than you've already paid.
Yes, and as long as you keep the key secure, no one else can decrypt it somewhere in the cloud or grab the files because they're all encrypted and it's just gibberish to them. They don't understand what it is. Check out Tarsnap and make backups. Okay, feedback and questions time. Neutron Damon has written us about a tutorial request. So that one goes. I have been tasked with installing a ticketing system for my work. I looked up in the ports tree because this would be a good opportunity to put BSD in my work site. I like how you think. That is purely Windows at this point, and saw that OTRS, the Open Ticket Request System, was available. I then searched tutorials, and it seems like even the ones on FreeBSD.org are A, derived from people that installed them in Linux, which means they have to do soft links and other tricks to get them to work on BSD, and B, outdated. So can you guys do a tutorial on how to install OTRS on FreeBSD? And this might be too much to ask, but if we can do it on Nginx instead of Apache, thank you guys for your help. That would be appreciated.
See, at work, we use a different ticket system out of the ports tree. We use Request Tracker, which I think is in the port trees as like RT42 because it's a version 4.2. Mm-hmm. But I've installed OTRS before. And I definitely didn't have to symlink anything around or anything crazy like that.
Yeah, so the easiest thing is package install. So that gets you the software.
Right.
But the config is different.
Configure the Nginx and probably like FCGI wrap or something to deal with the Perl for you. And it should be pretty straightforward. I'm also interested where you found a tutorial on freebsd.org that was derived from Linux. Maybe forums is maybe
it could be.
Because
that might be a spot. Yeah,
I don't think the handbook has anything about OTRS.
No, I haven't seen one.
So I've run OTRS on FreeBSD many times in the past. I've not done it in the last 5 years because I've been using RT instead.
Yeah, I think that's nothing specific to OTRS. That's Linux specific, which makes it not run on FreeBSD or any other BSDs.
Well,
so
it's in the ports tree, so it definitely runs. It's pure Perl, so it's.
I guess it's the config part. That,
I'd have to look, but generally, like I think on the OTRS website, they have the instructions for configuring the web server for it, and I'm sure they'll have Nginx in there.
Or our listeners have just recently done something like that, and they can send us a link to their instructions or a blog post that will detail the steps, and we'll cover it in the future.
If you happen to figure it out, Neutron Damon, write the tutorial for us. We would love that. Thank you.
Yeah. And submit that to EuroBSDCon while you're there. See? All right. Next up is Kurt with a question about transferability and bidirectionality of ZFS snapshots and send and receive. I see. This one starts, hi, Alan and Benedict. Thank you for the show each week. Sure, no problem. I have a question about a ZFS situation I'm facing, which is the replacement of my main disk in my computer. I've been using snapshots and ZFS send to back up the current main disk, so that currently the main disk and the backup disk have a dozen or more monthly snapshots that correspond to each other. So the question is, and perhaps it is silly to ask because the designers of ZFS seem to have anticipated nearly every need, if I transfer snapshots from the original from my main disk to the new source disk, can those snapshots be used as the basis for updating the backup with ZFS send going forward? To put that concretely, if the original source disk has snapshot April 2018 and the backup disk has April 2018, can I transfer April 2018 to the new disk and then do an incremental send based on April 2018 from the new disk to the backup in May 2018?
Yes. So while you attach arbitrary names to your snapshots inside ZFS, they have a globally unique ID. And so, yes, you can totally do an incremental from the new disk to your backup based on the common snapshot. It's the only way you can, but yes. So, no matter how many times a snapshot's been replicated to different pools and different machines or whatever, it's still actually the same physical snapshot, and you can use it for incremental. And that's one of the great things about ZFS.
Mm-hmm. And with the bookmarks feature, you can even delete parts of your sending snapshots.
Right. So the way that one works. So you have the April 2018 snapshot, which is what the system looked like right then. But it also means that you're keeping any of the data for files older than that snapshot that was been overwritten since. Whereas if you only have a bookmark, it's just basically the transaction number from when that snapshot was created. But it doesn't make you keep all the files, any data that's been overwritten since that snapshot. Because when you're doing the incremental, you only need the data that's been changed, not the data that's been deleted.
The delta.
Whereas the snapshot, you want to keep the data that's been deleted so that you can undelete it.
Yeah. Goes on. My other thought about this situation was perhaps I should send snapshots from the backup to the new disk, and then once everything is caught up and the same snapshots exist in both places, then turn the direction around. Start using the new disk and then send new snapshots generated on the new disk in the other direction back to the backup.
Yep.
I hope that is clear.
I do something very similar when I travel. I ZFS send all of my working file data sets from my NAS to my laptop, work on them at the conference, then make another snapshot and replicate it back to my NAS, and then go back to working off my NAS. It works very nice. Again, because every snapshot's the GUIDs, it doesn't care which direction they're going.
Yeah.
As long as you keep the common snapshots so you have a starting place for your incremental replication, it just works. Just don't end up in the situation where you've modified a file on both sides. But since your backup is going to be read-only, basically, it'll be completely safe.
Mm-hmm. Yeah, if that spark of genius strikes at the conference and you really want to implement this, and then when you're home, sync this back, and that works. It's not a one-way street. Okay, hope we answered that question. There's more details, of course, in the ZFS books, ZFS Mastery, and there's also ways to find this out on the web.
There's no book called ZFS Mastery.
FreeBSD Mastery ZFS, isn't that the one? Okay.
Yes. And then FreeBSD Mastery Advanced ZFS. Anyway, on to the question.
Sure. That one is from Peter. A question about much... a question about much love. No, a question and much love for BSD Now. Okay. Hi, Benedict. Alan. First, I want to thank you for the many years of high-quality content, where for me, it's just the second year. Alan has been at it a bit longer.
Yeah, we're getting pretty close to 5 years of this. This is getting crazy.
So he's a computer engineer by study and spent plenty of time hacking the Linux kernel at school and at work, and discovered your show recently, our show, and we've given him a sort of voyeuristic fascination with the goings on in the Beastie world. Come to the end of the semester, when I don't depend so heavily on my Debian-based toolchain for kernel hacking, he writes, I'm planning to give FreeBSD a whirl so I can try out all the new tricks you all show off with ZFS, jails, and virtual networking. Oh, this is just scratching that surface. There's much more. But I digress. My question is simply whether or not you're aware of a good free and open source software for two-factor authentication program, or failing that, one-time password generator. I love something that could integrate with PAM, but that I can protect SSH servers with a second factor of authentication. But I'm also interested in anything that either of you might be aware of.
So I have used OPIE. It's one-time passwords in everything is what it stands for. It's an old thing in FreeBSD. Like, I think it's based on MD5. I've thought of updating it and having making a mobile version of the password generator part for it, so that so the way it works is when it's enabled via PAM, when you go to log in with SSH, it will tell you the sequence number, and then either you have access to the original secret password or whatever and generate the one for that sequence number, or in the case of how I was using it years ago, I had an index card printed out with the sequence numbers and the passwords, which were made up of little like 4-letter words. So it's like if the sequence number is 55, you go on your little index card, find 55, and it would tell you like the 6 4-letter words that were the password. And that password would never be used again. I think the sequence number went down by 1 every time until it eventually got to 0, and then you had to generate a new set of them or whatever. But
that's part of the base system even.
Yeah, so this is part of the base system. But I'd love for somebody to update that to use newer cryptography than it does. It uses MD5, and it should use like scrypt or something. And make a mobile version of the generator so that instead of having that index card, I'd have the generator pre-set up with the right password or whatever. And then on my phone, I would just say, oh, the challenge I've been given is 712. I would type it in and it would tell me the right thing to type in to get the access going.
Yeah.
I know people have also used the Duo securities thing for two-factor.
Google Authenticator.
Also, yeah. And I think we've covered a tutorial on how to do that before. And we've also covered the one for Google Authenticator.
Yeah. And if you're looking if you're looking for more hardware stuff, then check out the YubiKeys, so that you need the hardware part.
Have you still not opened your YubiKey?
I sent 2. See, the other one is opened. Okay. 1 of 2. I get there. So, yeah, this might be another way of getting the second factor security added to that. Mm-hmm. And all of these integrate with PAM and SSH, so that works. And there are how-tos out there. You can find them. The next up is another Peter with a question about NetGraph state. That's quick and easy. I've been watching BSD Now. He writes, for a long time. Nice show. Keep going. Thank you. The question is, what is the status and the future of the NetGraph?
So NetGraph is great. It works. I don't know that anybody's doing much with it. I don't know that it's changing much nowadays, but that's because it works. And
yeah, sometimes there are more developments in individual NetGraph modules, like updates or simple fixes. But I see no big things. It works. It's part of the system. People use it. It's not something abandoned or outdated for too long. So there's nothing more to say. Maybe the how-tos on the handbook may not be reflecting the latest state, but that needs a little bit.
I think they are, because the NetGraph hasn't really changed. It was built and it works, and it's all good.
Yeah, just try it out. It will do its thing.
I don't know. I've never actually used it for anything. Mostly because I haven't had a need, not because it's not any good or anything like that.
Yeah, if you're heavily in networking involved, then there are ways for NetGraph to be useful. Mm-hmm. Okay, that sums it up. again, if you have any questions like these or want to contribute to our show with a tutorial or a nice BSD specific article or blog post that you found, send it to feedback@bsdnow.tv and we'll cover it in a future episode. Again, this is the episode for BSD Can. So while Alan and I and over 200 other people that have already registered having the times of our lives, you will get to watch this episode. And when we're back, we of course report all of the things that happened there.
Probably not all of the things.
The highlights.
Well, we will definitely make you sad that you didn't come.
Yeah, then you should already start planning for next year. Excellent. Yeah, enjoy the week.
See you next week.